All right, this is stoichiometry video number 4, where we're going to go over a couple of mixed practice problems. Okay, so this is number 7 in your packet. We've got one reaction that we're going to use for all of these 4 problems. It says hydrogen gas and nitrogen gas react to form ammonia. So here is our formula. N2 plus 3H2 yields 2NH3. So letter A says, if 2.5 moles of nitrogen react, how many moles of ammonia can be produced? So I always start with my given, 2.5 moles of nitrogen. So when I set up my conversion factor, whatever unit I start with, that unit goes at the bottom. So I have moles of nitrogen down here. Since I'm already in moles, and I'm going to have moles in my conversion factor, I use my coefficients from the balanced chemical reaction to switch from one substance to another. So I have 1 mole of nitrogen because that is my coefficient of the nitrogen in the reaction. And I've got 2 moles of ammonia up here. I do not have to use grams in this question or anything else because it's only talking about moles to moles. So I can go ahead and multiply 2.5 times 2, and that means I'm going to be able to make 5.0 moles of ammonia. Okay. And then letter B says, if 3.5 grams of hydrogen react, how many molecules of ammonia would be made? So I have 3.50 grams of hydrogen. I always start with my given. Now, whatever unit I start with, that unit has to come down here at the bottom. So I have to have grams of hydrogen down here. If I have grams, I use the molar mass from the periodic table. So that's 2.02. The molar mass is equal to 1 mole of hydrogen. I've got to get rid of the moles of hydrogen. So that means I have to have moles of hydrogen down here at the bottom. Now, since I'm going from moles on the top to moles on the bottom, and I need to switch from hydrogen to ammonia, I'm going to use the coefficients from my balanced equation. So I have 3 moles of hydrogen producing 2 moles of ammonia. I'm not done setting up my problem because I'm looking for molecules, so I have to keep going. So I've got moles of ammonia down here. I can only use that coefficient 1 time, so I'm back to using 1 mole of ammonia here. Since I'm looking for molecules, that means I've got to use Avogadro's number with molecules. So I have 6.02 times 10 to the 23 cules of ammonia. And I'm looking for cules. I've got molecules on the top, so I'm done setting up my problem. I'm going to have 3.5 divided by 2.02 because it's in the bottom, times 2, it's in the top, divided by 3 because it's in the bottom, times 6.02 second EE, 23. I get 3 sig figs because of 3.50. So my answer would be rounded as 6.95 times 10 to the 23 cules of NH3. All right, let's take a look at letter C. Okay, same reaction. Here's letter C. So I've got 0.60 grams of ammonia, and I am looking for grams of nitrogen. So I'm going to multiply this by a conversion factor. I've got grams of ammonia here. I need to have grams of ammonia down here. And I've got grams, which means I have to look at the periodic table for the molar mass. So 17.04. And I know that the molar mass is equal to 1 mole. So I have 1 mole on the top. I'm looking for grams of nitrogen, though. I don't have grams of nitrogen, so I have to keep going. Since I've got moles of ammonia, I have moles of ammonia down here at the bottom. And this is where I will be switching from ammonia to nitrogen. So I have to use my coefficients, that mole ratio from the balanced equation. So 2 moles of ammonia are produced from 1 mole of nitrogen gas. I'm not done yet because I'm looking for grams. So I keep going. I've got moles of nitrogen up here. So I have to have moles of nitrogen down here. That means I'm going to have 1 mole of nitrogen. And I'm looking for grams. I know that 1 mole of nitrogen is going to equal 28.02 grams of nitrogen up here. So I can go ahead and solve. I've got 0.60 divided by 17.04 because it's in the bottom, divided by 2 because it's in the bottom, times 28.02 because it's in the top. I've got 2 sig figs, so my answer would be 0.49 grams of nitrogen. Ignore that number. I don't know where that came from. Okay, where's my, there we go. All right, so 3.6 moles of ammonia, 3.6 moles of ammonia are produced. How many grams of nitrogen gas would be needed? So this time, since I have moles here, I need to have moles down here. I'm not going to be using the molar mass of ammonia because I'm already in moles. It doesn't say anything about grams or mass of ammonia, so I don't need to use the molar mass of ammonia. I'm going to go straight into using that mole ratio. So I'd have 2 moles of ammonia down here for every 1 mole of nitrogen gas up here on the top. I do need to keep going though because it is asking me for grams of nitrogen gas. So I do have to have moles of nitrogen down here. I'm going to have 1 here because I've already used the coefficient from the equation. I'm looking for grams of nitrogen. So grams of nitrogen up here. Again, that's the molar mass, so 28.02 grams of nitrogen. So I would have 3.6 divided by 2 times 28.02, and I would get 2 sig figs. So my answer would be 50, which only has 1 sig fig. I can put a decimal point here, or I can write this in scientific notation, 5.0 times 10 to the 1. Either way, I would accept grams of nitrogen as my answer, okay? So if you have any questions about mole conversions and stoichiometry sequences, let me know. I'll be happy to help you guys, and good luck.